behavioral science, I suppose, is more subjective and mathematics and physics is more objective. Would that be the clear difference?
The idea basically is that where something is on that spectrum, and I've called it the spectrum of persuadability. You could call it the spectrum of intelligence or agency or something like that. I like the notion of the spectrum of persuadability because it's an engineering approach. It means that these are not things you can decide or have feelings about from a philosophical armchair. You have to make a hypothesis about which tools, which interaction protocols you're going to bring to a given system, and then we all get to find out how that worked out for you, right? So you could be wrong in many ways. In both directions, you can guess too high or too low or wrong in various ways, and then we can all find out how that's working out. And so I do think that the behavior of certain objects is well described by specific formal rules, and we call those things the subject of mathematics. And then there are some other things whose behavior really requires the kinds of tools that we use in behavioral cognitive neuroscience, and those are other kinds of minds that we think we study in biology or in psychology or other sciences.
Why are you using the term persuadability? Who are you persuading and of what?
Well,
in this context.
Yeah. The beginning of my work is very much in regenerative medicine, in bioengineering, things like that. So for those kinds of systems, the question is always, how do you get the system to do what you want it to do? So there are cells, there are molecular networks, there are materials, there are organs and tissues and synthetic beings and biobots and whatever. And so the idea is, if I want your cells to regrow a limb, for example, if you're injured and I want your cells to regrow a limb, I have many options. Some of those options are I'm going to micromanage all of the molecular events that have to happen, right? And there's an incredible number of those. Or maybe I just have to micromanage the cells and the stem cell kinds of signaling factors. Or maybe actually I can give the cells a very high level prompt that says, you really should build the limb and convince them to do it, right? And so which of those is possible? I mean, clearly people have a lot of intuitions about that. If you ask standard people in regenerative medicine and molecular biology, they're going to say, well, that convincing thing is crazy. What we really should be doing is talking to the cells, or better yet, the molecular networks. And in fact, all the excitement of the biological sciences today are at single molecule approaches and big data and genomics and all of that. The assumption is that going down is where the action is going to be, going down in scale, and I think that's wrong. But the thing that we can say for sure is that you can't guess that. You have to do experiments and you have to see, because you don't know where any given system is on that spectrum of persuadability. And it turns out that every time we look and we take tools from behavioral science, so learning, different kinds of training, different kinds of models that are used in active inference and surprise minimization and perceptual multi-stability and visual illusions and all these kinds of interesting things, stress perception and memory, active memory reconstruction, all these interesting things. When we apply them outside the brain to other kinds of living systems, we find novel discoveries and novel capabilities, actually being able to get the material to do new things that nobody had ever found before. And precisely because I think that people didn't look at it from those perspectives, they assumed that it was a low level kind of thing. So when I say persuadability, I mean different types of approaches. Right, and we all know if you want to persuade your wind-up clock to do something, you're not going to argue with it or make it feel guilty or anything. You're going to have to get in there with a wrench and you're going to have to tune it up and do whatever. If you want to do that same thing to a cell or a thermostat or an animal or a human, you're going to be using other sets of tools that we've given other names to. And so that's now of course that spectrum, the important thing is that as you get to the right of that spectrum, as the agency of the system goes up, it is no longer just about persuading it to do things. It's a bidirectional relationship, what Richard Watson would call a mutual vulnerable knowing. So the idea is that on the right side of that spectrum, when systems reach the higher levels of agency, the idea is that you're willing to let that system persuade you of things as well. In molecular biology, you do things, hopefully the system does what you want to do, but you haven't changed. You're still exactly the way you came in. But on the right side of that spectrum, if you're having interactions with even cells, but certainly, dogs, other animals, maybe other creatures soon, you're not the same at the end of that interaction as you were going in. It's a mutual bidirectional relationship. So it's not just you persuading something else. It's not you pushing things. It's a mutual bidirectional set of persuasions, whether those are purely intellectual or of other kinds.
So in order to be effective at persuading an intelligent being, you yourself have to be persuadable. So the closer in intelligence you are to the thing you're trying to persuade, the more persuadable you have to become. Hence the mutual vulnerable knowing. What a term.
Yeah, Richard. You should talk to Richard as well. He's an amazing guy, and he's got some very interesting ideas about the intersection of cognition and evolution. But I think what you bring up is very important because um, there has to be a kind of impedance match between what you're looking for and the tools that you're using. I think the reason physics always sees mechanism and not minds is that physics uses low agency tools. You've got voltmeters and rulers and things like this. And if you use those tools as your interface, all you're ever going to see is mechanisms and those kinds of things. If you want to see minds, you have to use a mind, right? There has to be some degree of resonance between your interface and the thing you're hoping to find.
You said this about physics before. Can you just linger on that, like expand on it, what you mean? Why physics is not enough to understand life, to understand mind, to understand intelligence? You make a lot of controversial statements with your work. That's one of them, because there are a lot of physicists that believe they can understand life, the emergence of life, the origin of intelligence using the tools of physics.
Yeah.
In fact, all the other tools are a distraction to those folks. If you want to understand fundamentally anything, you have to start at physics to them. And you're saying, no, physics is not enough.
Here's the issue. Everything here hangs on what it means to understand. Okay. For me, because understand doesn't just mean have some sort of pleasing model that seems to capture some important aspect of what's going on. It also means that you have to be generative and creative in terms of capabilities. And so for me, that means if I tell you this is what I think about cognition in cells and tissues, it means, for example, that I think we're going to be able to take those ideas and use them to produce new regenerative medicine that actually helps people in various ways, right? It's just an example. So if you think as a physicist, you're going to have a complete understanding of what's going on from that perspective of fields and particles and who knows what else is at the bottom there. Does that mean then that when somebody is missing a finger or has a psychological problem or has these other high level issues that you have something for them, that you're going to be able to do something? Because my claim is that you're not going to. And even if you have some theory of physics that is completely compatible with everything that's going on, it's not enough. That's not specific enough to enable you to solve the problems you need to solve. In the end, when you need to solve those problems, the person you're going to go to is not a physicist. It's going to be either a biologist or a psychiatrist or who knows, but it's not going to be a physicist. And the simple example is this. Let's say someone comes in here and tells you a beautiful mathematical proof. Okay, it's just really deep and beautiful, and there's a physicist nearby, and he says, "Well, I know exactly what happened. There were some air particles that moved from that guy's mouth to your ear. I see what goes on. It moved the cilia in your ear, and the electrical signals went up to your brain. I mean, we have a complete accounting of what happened, done and done." But if you want to understand what's the more important aspect of that interaction, it's not going to be found in the physics department. It's going to be found in the math department. So that's my only claim is that physics is an amazing lens with which to view the world, but you're capturing certain things. And if you want to stretch to sort of encompass these other things, it's just we just don't call that physics anymore, right? We call that something else.
Okay, but you're kind of speaking about the super complex organisms. Can we go to the simplest possible thing where you first take a step over the line, the Cartesian cut, as you've called it, from the non-mind to mind, from the non-living to living? The simplest possible thing. Isn't that in the realm of physics to understand? How do we understand that first step where you're like, that thing is no mind, probably non-living, and here's a living thing that has a mind? That line. I think that's a really interesting line. Maybe you can speak to the line as well. And can physics help us understand it?
Yeah, let's talk about, well, first of all, of course it can, meaning it can help, meaning that I'm not saying physics is not helpful. Of course it's helpful. It's a very important lens on one slice of what's going on in any of these systems. But I think the most important thing I can say about that question is I don't believe in any such line. I don't believe any of that exists. I think there is I think it's a continuum. I think we as humans like to demarcate areas on that continuum and give them names because it makes life easier. And then we have a lot of battles over, so-called category errors when people transgress those categories. I think most of those categories at this point, they may have done some good service at the beginning of when the scientific method was getting started and so on. I think at this point, they mostly hold back science. Many categories that we can talk about are at this point very harmful to progress, because what those categories do is they prevent you from porting tools. If you think that living things are fundamentally different from non-living things, or if you think that cognitive things are these like advanced brainy things that are very different from other kinds of systems, what you're not going to do is take the tools that are appropriate to these to these kind of cognitive systems, right? So the tools that have been developed in behavioral science and so on, you're never going to try them in other contexts because you've already decided that there's a categorical difference, that it would be a categorical error to apply them. And people say this to me all the time, is that you're making a category error. And as if these categories were given to us, from on high, and we have to obey them forevermore. The categories should change with the science. So I don't believe in any such line. And I think a physics story is very often a useful part of the story, but for most interesting things, it's not the entire story.
Okay. So if there's no line, is it still useful to talk about things like the origin of life? That's the one of the big open mysteries before us as a human civilization, as scientifically minded, curious Homo sapiens. How did this whole thing start? Are you saying there is no start? Is there a point where you could say that invention right there was the start of it all on Earth?
My suggestion is that much better than trying to, in my experience, much better than trying to define any kind of a line. Okay, because inevitably, I've never found, and people try to, we play this game all the time. When I make my continuum claim, then people try to come up, okay, well, what about this? What about this? And I haven't found one yet that really shoots that down. That you can't zoom in and say, yeah, okay, but right before then this happened, and then if we really look close, like here's a bunch of steps in between, right? Pretty much everything ends up being a continuum. But here's what I think is much more interesting than trying to make that line. I think what's really more useful is trying to understand the transformation process. What is it that happened to scale up? And I'll give you a really dumb example. And we always get into this because people often really don't like this continuum view. The word adult, right?
Mhm.
Everybody's going to say, look, I know what a baby is. I know what an adult is. You're crazy to say that there's no difference. I'm not saying there's no difference. What I'm saying is the word adult is really helpful in court because you just need to move things along. And so we've decided that if you're 18, you're an adult. However, what it hides is what it completely conceals is the fact that, first of all, nothing happens on your 18th birthday, right? That's special. Second, if you actually look at the data, the car rental companies actually have a much better estimate because they actually look at the accident statistics and they'll say it's about 25 is really what you're looking for, right? So theirs is a little better. It's less arbitrary. But in either case, what it's hiding is the fact that we do not have a good story of what happened from the time that you were an egg to the time that you're the supposed adult, and what is the scaling of personal responsibility, decision-making, judgment. Like, these are deep, fundamental questions. Nobody wants to get into that every time somebody, has a traffic ticket. And so, okay, so we've just decided that there's this adult idea. And of course, it does come up in court because then somebody has a brain tumor or somebody's eaten too many Twinkies or something has happened. You say, look, that wasn't me. Whoever did that, I was on drugs. Well, why'd you take the drugs? Well, that was yesterday me. Today, this is right. So we get into these very deep questions that are completely glossed over by this idea of an adult. So I think once you start scratching the surface, most of these categories are like that. They're convenient and they're good. It's I get into this with neurons all the time. I'll ask people, what's a neuron? Like, what's really a neuron? And yes, if you're in neurobiology 101, of course, you just say, look, these are what neurons look like. Let's just study the neuroanatomy and we're done. But if you really want to understand what's going on, well, neurons develop from other types of cells, and that was a slow and gradual process. And most of the cells in your body do the things that neurons do. So what really is a neuron, right? So once you start scratching this happens. And I have some things that I think are coming out of our lab and others that are, I think, very interesting about the origin of life. But I don't think it's about finding that one boom. Like this is, yeah, there are innovations, right? There are innovations that allow you to scale in an amazing way for sure. And there are lots of people that study those, right? So things that thermodynamic kind of metabolic things and all kinds of architectures and so on. But I don't think it's about finding a line. I think it's about finding a scaling process.
The scaling process. But then there's more rapid scaling and there's slower scaling. So innovation, invention, I think is useful to understand so you can predict how likely it is on other planets, for example, or to be able to describe the likelihood of these kinds of phenomena happening in certain kinds of environments. Again, specifically in answering how many alien civilizations there are. That's why it's useful, but it's also useful on a scientific level to have categories, not just because it makes us feel good and fuzzy inside, but because it makes conversation possible and productive. I think if everything is a spectrum, it becomes difficult to make concrete statements. I think, like we even use the terms of biology and physics; those are categories. Technically, it's all the same thing, really. Fundamentally, it's all the same. There's no difference in biology and physics, but it's a useful category. If you go to the physics department and the biology department, those people are different in some kind of categorical way. So somehow, I don't know what the chicken or the egg is, but the categories, maybe the categories create themselves because of the way we think about them and use them in language, but it does seem useful.
Let me make the opposite argument. They're absolutely useful. They're useful specifically when you want to gloss over certain things.
Hmm.
The categories are exactly useful when there's a whole bunch of stuff. And this is what's important about science is like the art of being able to say something without first having to say everything, right? Which would
Yes.
make it impossible. So categories are great when you want to say, look, I know there's a bunch of stuff hidden here. I'm going to ignore all that and we're just going to let's get on with this particular thing. And all of that is great as long as you don't lose track of the stuff that you glossed over. And that was what I'm afraid is happening in a lot of different ways. And in terms of look, I'm very interested in life, beyond Earth and all of these kinds of things. Although we should also talk about what I call SUTI, SUTI, the search for unconventional terrestrial intelligences. I think we got much bigger issues than actually recognizing aliens off Earth. But I'll make this claim: I think the categorical stuff is actually hurting that search, because if we try to define categories with the kinds of criteria that we've gotten used to, we are going to be very poorly set up to recognize life in novel embodiments. I think we have a kind of mind blindness. I think this is really key. It's much to me. The cognitive spectrum is much more interesting than the spectrum of life. I think really what we're talking about is a spectrum of cognition, and uh, I know it's weird as a biologist to say I don't think life is all that interesting a category. I think the categories of different types of minds I think is extremely interesting, and to the extent that we think our categories are complete and are cutting nature at its joints, we are going to be very poorly placed to recognize novel systems. So, for example, a lot of people will say, "Well, this is intelligent and this isn't." Right, and there's a binary thing, and that's useful. And occasionally, that's useful for some things. I would like to say instead of that, let's admit that we have a spectrum, but instead of just saying, oh look, everything's intelligent, right? Because if you do that, you're right, you can't do anything after that. What I'd like to say instead is no, you have to be very specific as to what kind and how much. In other words, what problem space is it operating in? What kind of mind does it have? What kind of cognitive capacities does it have? You have to actually be much more specific, and we can even name, right? That's fine. We can name different types of, this is doing predictive processing, this can't do that, but it can form memories. What kind? Well, habituation and sensitization, but not associative conditioning. Like, it's fine to have categories for specific capabilities, but it actually, I think it actually makes for much more rigorous discussions, because it makes you say, what is it that you're claiming this thing does? And it works in both directions. So some people will say, well, that's a cell. That can't be intelligent. And I'll say, well, let's be very specific. Here are some claims about, here's some problem solving that it's doing. Tell me why that doesn't, why doesn't that match? Or in the opposite direction, somebody comes to me and says, you're right. The whole solar system, man, it's just like this amazing. I'm like, well, okay, well, what is it doing? Like, tell me what tools of cognitive and behavioral science are you using to reach that conclusion, right? And so I think it's actually much more productive to take this operational stance and say, tell me what protocols you think you can deploy with this thing, that would lead you to use these terms.
To have a bit of a meta conversation about the conversation, I should say that part of the persuadability argument that we two intelligent creatures are doing is me playing devil's advocate every once in a while, and you did the same, which is kind of interesting, taking the opposite view and see what comes out. Because you don't know the result of the argument until you have the argument, and it seems productive to just take the other side of the argument.
For sure. It's a very important thinking aid to, first of all, what they call steel manning, right? To try to make the strongest possible case for the other side, and to ask yourself, okay, what are all the places that I'm sort of glossing over because I don't know exactly what to say, and where are all the holes in the argument, and what would a really good critique really look like? Yeah.